This is a nice quick example. I just took this out of the book as well, it's just useful to know. When you're looking at polygons of vectors, so shapes made up of vectors, you just have to consider the direction the vectors are going and where you're going from and to. So for example, here in this triangle, you can see the vector AB and the vector BC. If you were to travel along AB and then along BC, you could get from A to C. So that's what's represented here with this expression. Okay, A to B plus B to C equals A to C. Now something like this, and what I should also note here too, is that you're starting at a particular point and ending at a different point. Now this example here, if we're looking at this hexagon, if we start at a point, let's say A, we can go A to B, plus B to C, plus C to D, plus D to E, plus E to F, plus F to A. What happens is that we actually end up at exactly the same point, so we haven't gone anywhere. So adding everything together actually gets you back to the start. But remember that we're not going to write this as 0 because we were dealing with vectors. We write it as the 0 vector. So it would be a vector, here it's in bold because it's out of the textbook, but by hand you'd write that as the 0 with the tilde underneath because it's the 0 vector. You've travelled nowhere. So this example here says illustrate the vector sum of AB to BC to CD, where A, B, C and D are points in the plane. Okay. Now you can put these points anywhere you want. First thing I'm going to do, I'm just going to put an A and a B. That's my A, that's my B. Okay, the next one I'm going to do, I'm going to put a C somewhere. That's C, so B to C. And then we want C to D. I'll just put the D here. Now, of course, you could put these anywhere. You could put them crossing over. But the thing to do with something like this is just make it simple. Put them spaced out a little bit so that you can see that clearly. And it says illustrate the vector sum of AB plus BC plus CD. So I'll do that in a different colour, do it in red. So that would be the vector that goes from A along to B to C to D to end up here. So the starting point and the end point. So we'd merely have a vector that goes from the starting point of A to the end point of D. So that would mean that AB plus BC plus CD equals simply going from A to D. So this is the graphical representation illustrating that vector sum and then actually showing with your vector algebra what would that sum be, adding all those pieces together. Well, it's that vector from A to D.